All right, welcome to Chapter 5 of AP Calculus. Chapter 5 is really going to be focused on applications of derivatives. Why do we use derivatives? When do we use them? What do we use them for? And so on. So we're going to start in section 5.1 by talking about extreme values of functions. And values of functions, it's sort of nice to know, what's the most I could do? What's the least I could use? That kind of thing. So this is going to be all about extreme functions. And let's go ahead and get started. So first thing we need to know, definition. Yes, definitions is the first thing. F of C is an absolute maximum if f of x is less than or equal to f of c for all x. All x in the domain of f of x. Seems pretty self-evident, but look at all the values of the function, and if they're all less than that one, then that one must be the maximum, less than or equal to. All right. F of c is an absolute minimum. Sure, you can see where this is going. If f of x is greater than or equal to f of c for all x in the domain of the function. So in other words, if every value in the function, every y value in the function is above or equal to some number, well, then that number is the absolute minimum. So quick example, and we're looking at the interval negative pi over 2 to pi over 2. And if we look at f of x equals cosine of x, we know that cosine looks like this. There's 0, and there's negative pi over 2, and there's pi over 2. So the absolute maximum is f of x equals 1 at x equals 0, and the absolute minimum is f of x equals 0 at x equals plus or minus pi over 2. So notice the minimum, it does occur twice, but it is still a minimum because it is 0 at both of those. So the absolute minimum of this function is 0. If you're in my class, why don't you go ahead and do exercise 1 in section 5.1. And when you come back, we'll look at some more examples of notation and absolute minima and maxima. All right, example 2. Function, domain, and extrema. And I'm just going to go through a few functions to give you examples of what this looks like. So for example, y equals x squared. Domain, negative infinity to infinity. And we have no maximum. So we do indeed say maximum none, and minimum 0 at x equals 0. And it's important to get into the habit of saying that the minimum occurs. This is the value of the minimum, and here's where it happens. Okay, y equals x squared, but this time on the interval 0 to 2. We have a maximum of 4 at x equals 2, we have a minimum of 0 at x equals 0. Notice in the domain. So we're only interested in the numbers between 0 and 2. Same function, but this time we're going to do the left bound be an open-ended interval, which means that this has a maximum of 4 at x equals 2, but it has no minimum. When you can continue to get infinitesimally close to x equals 0, you just keep going down and down and down and down. You're never actually going to get to 0. And finally, let's look at y equals x squared, but let's look at an open-ended interval 0 and 2. And this has no minimum or maximum because, again, you never get to 0, you never get to 2. You can just continue to get in closer and closer and closer. So, my students, go ahead and do exercise 3. And we'll be right back with the next thing. All right. I think we'll stop there, actually. Super short video to just introduce a couple concepts. But I think we'll stop there because we're going to come back with a theorem, the extreme value theorem, on the next video. So we'll make this short, and we'll see you on the next video. Thanks for watching.